So additionally to that, I'm a data scientist in the Mexico team, and I have been here since 2021. So it's awesome to be here with you. And today I want to talk about monitoring models with models. This is the adversarial monitoring. So next, please. First of all, what is feature drift? The next, please. As we saw with KK, models are constantly changing, right? So monitoring tools are super essential to better understand our data, the data that we are using in our models, to maintain these models, and more than that, if necessary, to implement an action to not affect our decision process, right? So the next, please. One of the main challenges in monitoring models is data drift. And what is data drift? Data drift is presenting when a feature starts to follow another distribution over the time. So for example, here, this feature is following the orange distribution in the training period, but then change it, and now it's following the purple distribution in the production period. So this variable has changed. This is very important because if our features, if our input data change, then our model is going to change. And this is going to impact our decisions, right? So it is essential to detect the data drifting, and also why is happening the data drifting. So next, please. There are some tools to detect data drift. For example, the Kolmogorov-Smirnov statistic, stability population index, and also the chi-squared statistic. All of these are amazing tools, are based on distribution analysis, but are focused to answer what feature is drifting, but maybe they are not focused to answer why is this drifting, okay? So next one. Here the question is, could it be possible to get more information about the feature drift? This is, why are the features drifting, and what is the impact of the drifting in the model? Next, please. So in order to answer this question, in order to get more information about the drifting, we have implemented we have adapted the adversarial methodology. And in order to define it, let's suppose that we have trained a risk model. Okay, we have trained a risk model in the first period, the training period, and it has been in production for a while. Okay, from now we will call this model original model. So we want to do the model monitoring, and in order to remark the feature drift, let's analyze some features. Next one, please. So for example, if we have feature 1, and what we can see is that the distributions between the training and production period are very similar. So we are okay with this feature. It looks like the distribution is not changing. But the next one, if we see feature 2, it is clearly changing the distribution, right? the orange distribution is completely different from the purple distribution that is now in production. The values has been changing, the values has been increasing, and now they are around 800. Okay, so oh no, here we have feature drifting. So what can we do about it? Let's face the feature drift. The next one. So what is the adversarial methodology? The adversarial methodology is a binary classifier trained to predict if a sample belongs to the training period. The last one, please. Yeah. In order to construct this classifier, let's define first, what is the adversarial target? We're going to label as 1 if an observation is in the training period, and as 0 if an observation belongs to the production period. Okay. Now, the predicted features that we're going to use in this classifier are the same that we use in the original model. Okay, so let's train our classifier. The next one. The flow is going to be as follows. First, as you can see, we have the data labeled with the adversarial target and with our original features. Then we train the adversarial classifier, and here the question is, can the classifier distinguish between the training and the production data? And to answer this question, we can compute the agency and the feature importance. Okay, the next one. So in this case, if the agency of the adversarial classifier is near to 0.5, then there is no feature with drift because our classifier is not distinguished between the training and production data. But in contrast, if the agency is greater than 0.5, there are potential features with drift. Our classifier is distinguishing between the training and production data. For example, the next one. If we train the adversarial classifier for our original model, we have this raw curve and the agency is near to 0.9. So here clearly we have features drifting because our classifier is distinguishing between the training and the production data. But what else can we do? The next one. The question here is, what are the features with the highest drifting? The next, please. So in order to answer this, we can use the feature importance or the SHAP analysis in this case from the adversarial classifier to show the features that are drifting the most, that are changing the most. So as you can see here, we can see that if the feature 8, the feature 9, and the feature 2 from internal data source are changing the most. These are the top 3 features that are changing the most. But okay, that's fine. This is great. But what else can we do, or what else can we analyze from the SHAP analysis? The next, please. Well, super important. More than that, we can the SHAP analysis can provide insights on the cause of the drift, on the why of the drift. For example, we have the feature 8 internal. Okay, so what we can see here is that there is a linear relation between the value of this feature and the adversarial score. In other words, the higher the value of this feature, the more likely to belong to the production period. And the lower the value of this feature, the more likely to belong to the training period, okay? So what we can see is that this feature is changing. And more than that, this feature is increasing its value over the time. So what they're seeing is that, again, the orange distribution was the distribution in the training period, and now it increases the value of this feature, and now we have the purple distribution. It increased its value. So it's amazing because now we can infer what's happening with the distribution, how it's changing the distribution over the time. We can analyze the why of the feature drifting. The next one. What else can we do? Additionally to the feature drifting, we can also analyze the null values, for example. So let's see the feature 5 internal. What we can see here is that the observations with null values are correlated with a higher adversarial score. This is, observations with null values are more likely to belong to the training period, okay? So what we can see here in the plot is that the percentage of null values level is changing definitely from the training to the production period. In the training period, we have around 4% of null values, exactly, of null values, and then we don't have null values, or we almost don't have null values, okay? So this is super useful because we are not just analyzing the data drift, we can analyze with the SHAP analysis other characteristics from our features. For example, this thing, the null values, okay? So the SHAP analysis is kind of pretty in this case. Can we go to the next one? Now, can we go deeper with this methodology? The next one, is it possible to be more flexible? Okay, want to go deeper. Let's suppose that we have 3 types of data sources. Bureau, we also have a fraud data provider, and also we have internal features, okay? What we can do here is, let's run an adversarial classifier per data source. So in this case, we can detect if the features with the higher drift are concentrated in some of our data sources. In this example, Bureau is kind of okay. Fraud, here we have some features with drift, but internal is kind of alarming. Here we have like some features with a lot of drift because the agency is super high in this data source. So this is kind of great because the adversarial can be super flexible to analyze this kind of characteristics from our data. The next one. Now, the question, how important are the features with drift to the original model? How can we relate the adversarial methodology to our original model? Next one. So let's define this plot. For each feature, we can plot this thing. We can plot the importance in the original model, how important is the feature to our risk model, versus the importance in the adversarial. In other words, how much this feature is drifting. So in this way, we can directly analyze or relate the features that are drifting with the importance of the model. How important is the features with drift to the original model? And for example, here we have the yellow point in the upper side of the plot. There, this feature is drifting a lot, it's changing a lot over time. Nevertheless, it's not so important to the model, okay? In contrast, the blue point in the right of the plot is super important to the model, but it is presenting not so high level of drifting, right? So the natural question here is, can we remove the yellow point and reevaluate the performance of the original model? The next one. The last, yes. So depending on the use case, we could define different thresholds to indicate if we should remove some variables. For example, here we can define the red area, and all of the features that are here should be removed, right? So this way, it's great because we can create like an iterative methodology, right? Like, okay, first I'm going to test, remove the feature with the highest drift. Okay, how is the model performance in the original model? Okay, that's acceptable. Okay, the next one, I remove it, and now how is the performance in the original model? And then we are taking care of the instabilities in our model, but at the same time we are taking care of the performance, right? So in this way, we are optimizing for both sides. So in summary, what do we have with the adversarial methodology? With adversarial methodology, we have number one, drift detection. With AGC and also with the shape analysis, we can determine if there are features drifting and what are these features. Second one, and this is great, the drift explainability, the why of the drift. How is the distribution of the features changing? How is this affecting to the model, okay? So the shape analysis here is crucial. The third one, the flexibility in summarizing the results. The flexibility is great because we can analyze the adversarial by data source or by other dimension that you want to analyze. The next one is the relation of the adversarial versus the original model. And here is great because we can directly analyze how important are the features drifting to the original model, right? And here, as we said, we can create like an iterative methodology to remove feature drift, but maintain our performance in the model. And finally, this is intuitive and also fun. Funny. The next one, please. So what are the next steps inside know about this methodology? We are now thinking on the implementation, right? This is our challenge now. And implementation, as I said, in the monitoring to detect this feature drifting, but also it can be implemented inside the feature selection, right? Okay, inside the feature selection pipeline, we can implement which feature is drifting. And in this stage, let's remove this feature and let's see how is this impacting to the model definition. And the next one, here's the reference in case you're interested. We have, as I said, this is an adaptation of this model, and we are iterating over this idea, making better this idea, and yes, that's what we are doing now. And the next one, thanks. It has been the presentation. It has been the adversarial methodology, and I don't know if you have any question. Happy to answer.
Thanks, Alejandro. And the people in the audience, we hope you enjoyed this presentation. The techniques shown here by Alejandro give a competitive advantage to data scientists because we're talking about very advanced techniques for a data scientist. So kudos. So people in the audience, let's move on to the Q&A session. We have gathered some questions. So team presenters, I will mention them, so feel free to answer them. So regarding the first presentation, the model monitoring, scaling model monitoring techniques, there's a very good question by an anonymous attendee. How do you use Sorry, I think I lost my Wi-Fi connection. Can you hear me?
Yes.
Yes.
Okay, so sorry about that. I lost my Wi-Fi connection. So regarding the first presentation, we have a very interesting question. How do you use user feedback to improve Shepherd? Kaique, could you please help us?
Okay. So basically, like what we used to do here at Nubank for most of our internal products is that we keep talking with the internal customers. So we had like intervals with them, and we kind of get feedback. So most of the things that we talked about, like the tool and how it works as of today, is mainly based on our internal customers' feedback. Because as I said during my presentation, for us as a platform team, it's really hard to really know like the business needs. So it's really important to keep in touch with all the different things and really understand how can we use software to solve their day-to-day problems. I think that's it.
Amazing. Thank you so much. Now let's move on to the second presentation questions that we have. There is a question that says, and Amadis Hector Ferreira, could you help us please? With all these tools, in what a data scientist focus its time? With all the geographies shared tools, could you help us please?
Yeah, I can give my perspective. So in our case, like the idea of this standardization and all the automation we are creating is more to like liberate the data scientists from the boring work, the work that is just like copy pasting, adjusting some variables, some parameters, and so on, and all this work that could be much that could happen much faster and with less difficulties, so that they can focus their time on more valuable things like analysis, thinking about new features for the models, or new ways of monitoring, or different approaches to impact the business directly. So that's the idea, in my view, of the tools and the processes that we have been automating with our inside customer access, for instance, at least.
Amazing. Any other thoughts on this, Amadis, Hector, or we can move on to the next question?
Well, I just would like to mention one thing really quickly, and is that in the end, yeah, as Gabriel said, like the tools that automate the work actually usually do things that that take us a lot of time and are somewhat repetitive. But and linking this to, for example, the last presentation from Alejandro, I think that the data scientists right now are much more involved in developing these new techniques and also proving these new techniques, such as the adversarial analysis, for example. And in the end, there are a lot of other things that multiple things that we can still do to increase the performance of our model, or study how the model behaves through time, for example. So in the end, I think that there are a lot of much other tasks, and in the end, we would like to automate them as well. In the end, however, there will always be new things to do in terms of improving in terms of how we improve our models.
Amazing. Thank you so much. And we still have time for one more question, and this time about the adversarial monitoring. There is a question by Marcos sorry about the presentation, Galbao, that says how to detect if the drift represents the real phenomenon changes. Alejandro, could you help us?
This is a wonderful question, I would say, because I think it's deeper than the adversarial methodology, right? Like, I think that if you want to represent the real phenomena, and if the real phenomena is a population that you are confronting, maybe I will ask to you, like, do you have like a sample, and can you create a sample that is representing the real population that you are confronting, or the population that you are confronting? If that case, and if the answer is yes, maybe you can adapt directly the adversarial methodology to represent what's happening in the real world, or in the population that you are confronting, right? I think that could be super helpful, because if you have that sample, yeah, that would be much more easier to infer if the data drift it's also happening in the real population.
Awesome. Thank you so much. We are well, almost on time, but I don't know if we want to answer one more question. Well, perhaps we can. What do you say, presenters? One more question?
Yeah, why not?
Why not? Okay, just to close this wonderful meetup. There is a question that says, and perhaps we can complement the first presentation with the last one. How could you create an out-of-the-box monitoring? Could you explain more about this challenge, please? Because right now you talked about adversarial monitoring, and Kaique also talked about the tools we are using to scale the way we monitor models. So, any thoughts on this?
I think I can start. Maybe Alejandro can go next. So our idea with out-of-box monitoring is that we do have some like set of models. So let's say we do have credit-related models, or we do have customer support-related models, and kind of those models do have some similarities. And let's say I do have my credit underwriting model here in Brazil, and I also will deploy the same model in Mexico and in Colombia. And kind of we do expect that all those models will have similar monitoring related tasks. So mainly our idea is to have something that allow data scientists to say, oh, this is a credit underwriting model, just deploy the regular set of monitoring dashboards and monitoring alerts that we as a company agree that will be useful. Or even like in some cases, as Alejandro talked about adversarial monitoring, maybe we do have a set of monitoring tasks that could be applied to any of our models. And we don't need to have a data scientist saying to the platform, do this for this specific model. Maybe we can just together with the deployment. And we already have a bunch of tasks that happen during the deployment that are out of box. So we do have out of box testing. We do have out of box governance tasks. So we think that we can do the same with monitoring. Not sure if Alejandro wants to provide some insights.
Yes, I agree with you. I think that the communication and the transparency across the teams, particularly data scientists and machine learning engineers, is very important, right? To have this out-of-the-box concept. And regarding the models, even with the adversarial is using like SHAPs or classifiers, if you see, we are trying to extract like the insights from here. We're trying to be like more like, yes, exactly, super clear about what is the SHAP saying to us, what is the agency saying to us, transformed to some intuitive things. So if you try to do that with your monitoring metrics, it doesn't matter if you are using the population stability index, the KS, etc. If you try to be clear with that, with your explanation, to translate it in actions, I think that's kind of the key, the communication and how clear you are with your metrics.
Amazing. Thanks for those great answers. So, audience people, thanks for attending this amazing meetup. And thanks to all the presenters. We will share this recording in our YouTube video, in our YouTube channel, Building New. Subscribe to it.